Hello, everybody. So, I'm Ernesto Boado. As he introduced, I'm from BGD Labs. And today I will be doing like a joint talk / workshop with Tomer from Certora. We kind of work together. So, first, a bit of what exactly is BGD Labs, because sometimes it's a bit confusing. So BGD Labs is a team that I co-created, which could be considered like a bit of a spin-off from the Aave DAO, from the Aave protocol. So for a bit of background, before I co-created the BGD Labs, I was CTO at Aave, the Aave Companies, which was the team that developed the Aave protocol, like from the V1 version, V2, currently V3. And then at the end of 2022, like following like the decentralization of basically everything, even of the organization, well, I decided like to create a separate team, a development team, and from beginning of 2023, so more than 1 year, no, from beginning of 2022, sorry, more than 1 year ago, we actually have been we passed like a proposal on the Aave DAO to be like the official like development team providing services to the DAO directly. So yeah, this is what is BGD Labs and which is the relation with Aave. So well, first of all, like a bit of like the style of my talk. I saw like, I mean, this is the DeFi Security Summit, so the big majority of the talks, for what I see, are coming from the top security professionals that we have here. I'm not really like a security professional. Like I know certain things about security, I think, at this stage, but I'm on the development side purely. So basically, that is the idea of the joint talk. That I will explain a bit my experience, like with formal verification, like in a quite production protocol we could call like Aave. And then like Tomer will go into the details like of exactly like how it really works in the practice, like on the different projects on where like Certora rules are applied into the Aave protocol. So yeah, mine will be more like a high level view and insights. Yeah. So first of all, like some common misconception. Is that like Aave is like this liquidity protocol on where people just goes, deposits collateral, borrow against, or some others just deposit multiple tokens and earn yield on them. Actually, it's a bit more complex than that, and there is quite more variety apart from that. So yeah, there is the liquidity protocol, and that is the thing that Aave is more well known for. But apart from that, there is like a governance system, on-chain system of smart contracts, like to vote and to actually take decisions on the Aave protocol itself of the liquidity. Yeah, there is like others like incentives management, like which is quite separate from the protocol itself, but connected to it. So whenever like somebody wants to give incentives for using the liquidity protocol. There is also like the so-called safety module, which is a method of protection, like if anything will go wrong on the liquidity protocol, hopefully not, the safety module on where like Aave holders' stake could actually be slashed to cover a potential loss. And yeah, the last piece is a stable coin that actually will be live tomorrow, I think, depending on when the proposal payload gets executed. But yeah, this is the last addition, so to the whole ecosystem. So as you can see, like basically almost all the parts of the DeFi puzzle, or even almost blockchain applications, like were touched and they are covered by Aave one way or another. So, yeah, this is more about like the insights of how exactly like security is managed in Aave, how is our approach, and especially how it evolved over time. Because well, we are doing this like for already, I think, 3 years, like since Aave V1, and things have really changed. I would say the same as with the security ecosystem itself. So, well, as the big majority, I think, is aware, like this is important is before deploying smart contracts, as once the protocol is live, obviously there is way more other stuff to take into account. But before deploying certain smart contracts, what exactly do we do? Like what we did like in Aave back in the days, what we are doing now in BGD Labs, and so on. So it starts with testing. With testing, I think almost everybody is familiar. I'm referring with unit testing, like with certain integration testing of different independent system of smart contracts, sometimes not smart contracts, like so. Let's say the classical testing in software, as everybody understands, I think. The peer review is pretty important, like so internally the team, whatever is the team, like because with decentralization sometimes it's not exactly the same team, but there is always like steps on where you review the code of each other and you check that everything is as it should be. The security reviews, which a lot of people call them like manual audits at the moment, and this is basically, let's say, snapshot reviews of external parties, which are experts in security. And once you think that the code is ready, peer review is finished, testing is robust, ideally everything, you forward or you engage like some third party security auditor that will like review everything and check that nothing was forgotten or there is no bug. And the final piece is the so-called formal verification, and it's important to highlight that I'm just using like in an informal way the formal verification concept to refer like mainly to what we are more familiar with and what we really use, that is like the Certora property check. So a bit of also background from where it comes, like the relation between Aave and Certora. First, well, it actually starts a bit before of the first step of Aave V2, but V2 was the first formal step. So back in the days when also Certora, I think, was starting, they were reviewing like multiple live smart contracts out there, and one of the ones that checked in detail, even if Aave didn't really ask, was like the Aave smart contracts. And well, first of all, like they found like some interesting stuff, and second, like that the approach that they brought to the table was quite different, like to everything that we were doing before, which nowadays maybe doesn't seem so special, like, but back in the days, like when running Aave V1, and especially when Aave V1 was really growing to big numbers, like we were just really looking for everything that you can imagine in terms of security. So after this initial contact, let's say, with Aave V2, we already, like, when I was like on Aave, on the Genesis team, like we engaged with Certora, like for basically like a review and also like for formal verification to apply their technology of property checking on the Aave protocol. In this case, the liquidity protocol. This continued with Aave V3, more or less the same. So like property checking, but to the new iteration of the protocol. And things got like even more interesting with, I think, for sure, like more than 1 year ago, when Certora, the same as with BGD Labs, like engaged directly with the Aave DAO, which basically with the smart contracts holding the permissions and the funds of the Aave system. For services like directly to the DAO, and basically, obviously, to the development contributors to the DAO itself. So now, yeah, I explained a bit of the context. So how exactly, that is the core here, like how exactly do we tackle like formal verification and property checking on Aave and BD Labs? So first of all, like it's important to understand like why we see value like on applying property checking, not only like what do we do. So Aave V1, V2, and 3, they are pretty complex systems, let's say. So not really like comparable with some other traditional software, I will say, but the nature, like the open nature, like the type of accounting that it has, tokenization, different types of flows, of user flows, and basically everything that is built on top makes it pretty complex, like even to reason about. So the quite typical thing that I say is that when we develop like Aave V1 and we released Aave V1, I think we learn like 50% about Aave V1 once like it was running. Not so much about the invariance, but in terms of like how people was using Aave V1. Then, because of this complexity, and precisely because you don't even know how people is using is going to use the system, or how like I don't know different other smart contracts are built on top, is not really easy, like to just do traditional testing, and especially be sure that your testing will cover all the cases, and you will not have any problem, and you will sleep at night when you have like $50 million in the platform. Then, obviously, we thought about fuzzing, that I think it was explained like in the 2 or 3 previous talks. And for us, like we even implemented on Aave V1 like a really small engine of kind of fuzzing, let's say, that we call scenarios. And the idea was like if you at least need to replicate certain conditions, certain scenarios on the protocol that you envision, and test based on that, and be able to generate those kind of scenarios automatically, let's say. Not exactly, but automatically. So we experiment a bit with that, but yeah, it gave us, we found during development problems using these scenarios. It gave us way more confidence, that is true. But at the end of the day, like we were not completely happy with that, because still, like you always have this insecurity that you don't really know how it's going to use your protocol out there. Then another point is that we did multiple audits on Aave V1. We did more on Aave V2, more on Aave V3, and still like we kept seeing the same that is like the security reviews, even from the top participants, like that I think a lot of them are around here, like they were missing something, and not really missing because the work was not well done. Then is when we noticed that it's just not so easy like, to notice which like these really edge cases. And then so formal verification. One of the main things of formal verification is that it catches certain types of bugs. I mean, it catches basically a lot of, or the majority of the bugs, depending on the code base. But even with well-tested code bases, like and well-audited code bases, still it catches like some bugs that are pretty dark, I would call it. Dark, I refer that like you don't really think in that direction while you are developing like a system. Another point of why formal verification is that, good practices in an early field like DeFi, like or smart contract developments, like they are always not so good. Ours at the beginning, for sure, were not the best and improved a lot. And the moment that we started like incorporating formal verification to our code, we we immediately noticed that we started thinking on having better documentation, better specification. In some cases, like we were doing some kind of technical paper, apart from certain white paper, but it's not exactly the same because you are not really defining the specification of the code, just the high-level idea of what is the system. And for me, the most important of all is that formal verification is a tool that allows you to protect against what you don't know, so the unknown. And this is like a quite critical point, especially like in a system like Aave. So you will have like malicious entities like trying to exploit a system that holds a lot of user funds all the time in a completely open environment, and with, in some cases, not so much chances like of having a solution once the event happens. So this is incredibly valuable. That if you can have any tool that gives you some predictability that it doesn't matter what happens on top, but the system should be safe always, and you don't know what could happen. So yeah, it feels like there's the holy grail here, like formal verification, and it should be applied on all the systems for everything and so on. But well, not exactly like that, at least from our perspective. So you can apply formal verification on, I think, almost any smart contract out there, because at the end of the day, it's a way of like checking that your specification and the code that you write are the same, like kind of the same. But I think it was mentioned in the previous talk that if you try to do formally verify like any system, like in a big percentage of the cases, like first of all, like the effort is incredibly high, which translates in cost of all types. And well, I mean, at least from our experience, in some cases it gives value, but it gives less value than in some others. So a bit of like rules of thumb of where we actually see like formal verification methods in practice, like shining. So if the system is having accounting, and with this, like I mean tokens, like or liquidity protocols of any kind, usually is quite a good idea. And this is for the simple reason that testing accounting sometimes is, I mean, you can test accounting, but certain edge cases, like it's not so easy to test them, and formal verification can really tell you it's impossible that you will reach this kind of accounting problem. And that is, it just simplifies a lot of other things. Then, whenever like there is like a complex in and outflow of assets, and in this case, like mainly DeFi protocols, this formal verification is also quite useful, because you can define like the properties based on how is the balance at certain point, how it should be, how it should never be, and everything built upon those. Yeah, another type of systems, this is a bit more abstract, but what I call asymmetric systems. This is here it shines quite a lot. And to put an example, like Aave is a really asymmetric system, even if it has a lot of symmetric pieces. So what I mean is that on Aave you have like a borrow side, you have a deposit side, and you have a collateral side. But then you can have situations on where like like an user deposits certain amount of tokens, and another user deposits the same amount of tokens, but one activates it as collateral and the other disables it as collateral. So it's basically, that creates an asymmetry of the system. And when you combine those asymmetries, like with then borrowing dynamics, or with liquidation dynamics, or with flash loan dynamics, then it becomes incredibly difficult to even understand what happens sometimes, and for sure to create like the scenarios that I mentioned before, to simulate the conditions on where some bug could happen. So yeah, this is the key. And then, yeah, whenever like a system respects a standard, this is like the most clear use case, I will say, because yeah, basically the property checking can be tried once, more or less, and then like whenever you inherit for implementation of that standard, like ERC20, you can and you put some custom logic, you can plug the property checking existing already of ERC20 and then add or customize it like for your own thing. So examples like of real systems on where like I can build that like formal verification helps. So Aave 3 for sure, there it shines, really important. SDK Aave v1.5 basically is like is a token, and it represents like the staked Aave on this backstop module, we can call it, the Aave safety module. SDK, both of them, I mean, Aave is the perfect example because it groups all the previous things that I mentioned. SDK Aave is basically an accounting system. It has also inflow and outflow, a bit asymmetric too, yeah. Then, yeah, we did like some wrapper smart contract, ERC4626, for the tokens of Aave. Like, the tokens of Aave have this peculiarity that they grow in balance. So whenever somebody deposits an asset on Aave and there is yield, like the balance of your token grows. Different to some other implementations like Compound, where the value grows and not the balance. So we build a wrapper that transforms between both of them, and given that it's really heavy on accounting, this is the key here, the formal verification is quite useful. Or, yeah, another example is like the Aave token itself, because the Aave token is I will explain a bit more later, but it's an upgradable token, like, and it has like voting dynamics and like delegation dynamics. So like it's also having multiple types of accounting, but I will go more in detail after. Then, what is not so nice, let's say, with formal verification? Any contract that has like purely arbitrary logic obviously is difficult to prove how it should be the behavior, because anything can happen. This is not even so much about like the formal verification itself, is that you intentionally want the system to be general, so it's pretty difficult to try to limit or verify that the system is not general because it's by design. So that is pretty obvious. Then cross-chain. Cross-chain systems, with this I refer that is designed that you do something on chain 1, network 1, and that reflects via some kind of breaching in the middle in network 2. In this case, I mean, it can be done, like, and it's useful, but for just the setup that you need to do and how you connect the two networks, like it is a bit more complicated, like to get formal verification, like in a perfect way, because it's more designed like for a system in isolation to start with. And then, yeah, whenever like there is like certain really small developments, like in the case of Aave, every time that a governance proposal needs to be submitted and passed, that is like a executable payload. Like, so usually it's not so useful like to formally verify or property check the payload itself. It could be useful, like, and it is useful, like, to do the same on the system that will get affected, but not really on the payload. Yeah, and as examples of this, so we build like on like this Aave and Starnet bridge, which is basically a contract on where like you put 8 tokens of Ethereum and it wraps them and bridges it to Starnet. So this is purely cross-chain, as you can imagine, and is more challenging. We did like formal verification with Certora, but yeah, it was more challenging than the others. Then Aave Governance v3, this I will explain more extensively just after. Well, this is challenging by itself because it combines the big majority of the steps that I say that are make difficult formal verification. Yeah, and certain proposal payloads on the Aave Governance, like is the point of small developments, not so much reason to formally verify that. But something really important about formal verification is that, and I think together with the be secure about the unknown, I would say this is the one that changed the most for us in practice, is that since we are like applying these techniques, like I feel that we understand better our code and we understand better our system. Because, I mean, it's a consequence of the good practices too. Like you kind of get forced like to have then less overhead on the property side. You get forced like to define natural language properties, first of all. So the moment that you start reasoning in terms of properties, like it opens to discussions with even internally with the team that leads you to really understand better your system. Yeah. And now, like, to finish my part, like before Tomer takes over, like we have two examples, and the idea is that I will present from the development side, like how exactly the system is, and then Tomer will go with some specific properties that were written, like from the specification. So, yeah, first of all, like the one I mentioned before, that is, it will be, by the way, like a good example, like another that is just more challenging. So the first is like the perfect one, which is an Aave token upgrade that we are planning to do and that we developed like the code already. So to refresh a bit about what has a special like just the token. So yeah, Aave token is an ERC20, it's a governance token, but is upgradable by the DAO, by the smart contracts of the Aave DAO itself. And because of this, yeah, I mean, and as it is a voting token, like at least until now, like it requires like to have like the so-called snapshots of balance, like, and also snapshots of delegation, because you can delegate your voting power to somebody else. So due to this, like, well, basically on every transfer of the Aave token, you need to do certain snapshots, like which is a voting snapshot, but also like for the call proposition power. So it makes it like quite gas expensive, like the token itself. And this hopefully could be optimized. With governance v3, and I will explain a bit later, but the idea is that the system doesn't require anymore like snapshots on the token to consider voting balance of an user at any point of time. And because of that, like obviously we decided like to remove the snapshot and make it cheaper, like the transfer of the token, because it just doesn't give any value to have it more expensive. So what actually, to take into account is that I participated like on the development of the first version of the Aave token time ago, and now I also participated on the new version of the Aave token. And before we were not applying formal verification, now we are applying. So what exactly changed like for us? So first of all is that the writing of the properties like is what I said before. Like it made a big change for us. Like because even while we were developing the system now on this new version, from almost the very beginning, like we were thinking first on the properties, and also like in even the edge cases that were detected by other systems properties. Like so that made like a big change, like on improving the quality of the development process. Then another thing is like that it kind of compresses the tests, like if we can call it that way. So the idea is that if you want to, you yeah, pretty complex token that has delegation, that has balance, and that it has like a lot of different combinations of how those fields are. So if you want to really test it, like you need to have a huge test through it and like simulate different scenarios and so on. But in the case of the token, it's pretty straightforward, let's say, to have like property checking that is like with one property, like you can cover like and have the same utility that like 100 tests, like of different kind of scenarios, varying a bit the inputs, let's say, state. Yeah, and the last is that for sure it gives us way more confidence on accounting, which when you look things into perspective, like is pretty important because you have like a token that is upgradable. So we, for example, like do modification of this, even of the storage layout in this case. And all of these will control the Aave DAO, which in turn controls the whole Aave thing. So the moment that you don't have like good confidence on what you are doing is not really a comfortable position like to develop with. Then on the other side, let's say, which is like a bit more complex side of the formal verification, we have the Aave Governance v3, which is radically different to the previous system. So what is exactly Governance v3? So, Governance v2 is, like I explained, just smart contracts where people vote on proposal payloads. If they pass, they get executed, and that creates like any kind of effect on the Aave ecosystem. In the case of Governance v3, the idea is still exactly the same, so a voting system of smart contracts with execution, but well, different to v2. v2 was running completely on Ethereum, that is where the Aave token lives. And then using like some bridging to bridge decisions for chains where Aave is. But now like Aave Governance v3 is cross-chain internally. What that means is that the proposals can be created wherever like they need to be executed. Then Ethereum acts like a settlement layer, which adds like the security. But then voting doesn't happen actually on Ethereum. It happens like on, let's say, cheaper networks because voting was really expensive and it was like a big barrier. So basically you have like this flow that is from network A that goes to Ethereum, that then goes maybe to network B to vote a proposal, then it comes back to Ethereum, and so on and so forth. Yeah, this is not so important in this context, but it's based on storage proofs, and that is how we do this, how we move the voting to another network, but based on the balance of Ethereum. And the most important part, like in regards of formal verification, is a pretty complex state machine going to the technicalities. So you have like a proposal lifecycle, and then you have proposal created, then is not active, then it goes like on voting state, but that is already in another chain, then it comes back, like it's a pretty complex state machine. Still, like what exactly, like it also improved like on our processes and how we see that these improvements are. So the verification of these state transitions, like of the state machine, like they became, well, more solid, clearly, because as you can imagine, if you have like 7 states and you want to properly test them, you need to simulate like the different jumps from one state to another, like and all the combinations of those, or majority of the combinations. Yeah, and with formal verification, it's a bit simpler, like because we have like pretty big invariants on the system that Tomer will comment, I think. So we just don't need to test some stuff. Then, as we have the property checked during the development process, it's not just something that gets done at the end. This, in practice, like allow us to discover bugs, like while we were developing. He will also explain, but like in typical cases that you create a PR, and you do some changes that seem completely safe, and then property checking just puts the red signal that you actually broke everything. So, yeah. And then this is actually quite important, and people tend to, it's not so simple to see, but when you develop like something that has so many components like Aave Governance v3, and you are reasoning in quite high level, like on the development process, you tend to oversee like things on the low level. Like at least is something that I saw multiple times, like not only on this. So property checking, as it is quite basic, if it's properly done, of course, but as it is quite basic, like on what exactly you define on the invariants, when some problem appears, is pretty low level, and basically it acts like a seatbelt, let's say, that against your high-level reasoning. And this is pretty important. So here, an example is that, sometimes you forget about like the ETH management, like, and there is maybe some edge case that it could be really problematic, and you don't really think about it because it's maybe an edge case that most probably will never happen, and these kind of things. But the property just detects it because it breaks an invariant, and then you can follow the flow, and actually you can improve the system just to cover the case. So those are about the two examples, and before like Tomer jumps, so a bit of summary like of the high level from the development perspective. So on Aave, like we try to use the formal verification, but not just like a hammer to apply everywhere, but we kind of think quite a lot on where we should and where we should not, especially in terms of priorities, for example, of projects, because we have a bunch of them. Understanding of the code is just game-changing. Like, basically, if you start to write the properties like in a document, you don't need any tool, you don't need anything. You will for sure understand way better your code than just jumping into Solidity. Dark bugs, like, so yeah, some type of bugs are difficult to see, even if you are the best developer out there. But the form verification just helps. And yeah, I mean, good practices, like it's just a side effect, what I mentioned on the initial point. And the most important one, again, is this is like quite local for Aave, but for anybody that is building a protocol, that a DeFi protocol especially, that plans to scale. From personal experience, I think I recommend that you apply all the tools that make you be more confident, because there will always be, like on open finance, like unknown. There will always be some malicious actors, even if they are not the majority. And well, like, yeah, having full confidence that nothing bad will happen is fundamental. And yeah, that's it. Now Tomer will go to the nitty-gritty details.